This conference will now be recorded.
Hello, everyone. Thank you for joining us. Jordan Girth from the National Weather Service Office of Observations here. We've got another great edition of the Satellite Book Club. This is session number 4, and we've got a great topic today, the Geostationary Lightning Mapper, and one of the foremost experts on that from NESDIS Star, Scott Rudlosky, is going to be presenting in a moment. Just a few announcements before we go ahead and get started here. First of all, this will be about a 15-minute presentation. Please mute your line for those of you that are in the audience. And given the number of attendees, if you have a question, just go ahead and ask that during the presentation, but put it in the window there. And if we need clarifying information from you during the Q&A portion, we'll go ahead and call on you at that time. That'll help us determine how much time to allot for the questions. If you're joining us from the National Weather Service today, we're always looking for future presenters. We want to keep this forum focused on field applications of satellite data, and so we're hoping we're meeting that need. So there's going to be a feedback survey that is available to you. So if you have any ideas for how we can make this more relevant, please let us know. For those of your colleagues that might not be able to join us due to shift work, we understand, and these are being posted and made available on the CLC to be watched after the live event here today. I do want to say special thanks to David Blutis, Lee Byerly, part of our Tower S team, who's available to help you with data access and AWIPS configurations. We also have a training team that can help create training materials for the science officers out there. Brian Mata, Ross Van Til, really appreciate the Forecast Decision Training Division helping us out with this. And of course, GOES-R and JPSS programs themselves, particularly Bill Schoberg, Dan Lindsay, Mitch Goldberg have been a huge asset in helping us get these off the ground. So thanks all the way around. This session is being recorded today, so please keep that in mind. And without further ado, I'd like to introduce Scott Rudlosky, who's a physical scientist over at ESSIC CISESS at the University of Maryland, and he's been coordinating a nationwide team supporting the Geostationary Lightning Mapper. So Scott, looking forward to what you have to present today. Thanks for being here.
Certainly. Thanks, Jordan. Appreciate the opportunity. I wanted to note too, part of the reason I was more than willing to help with this is the instrumental role the NWS Office of OBS and the Tower S team have played in getting the GLM products to the forecasters. So I'll continue the acknowledgments and thank you for that. Getting onto the talk here, I gave it a fairly redundant title here. You probably know the answer. What's better than one geostationary lightning mapper? Slide 2 shows that the 2 geostationary lightning mappers provides nearly twice the coverage, with the combined field of view covering most of the lightning in the Western Hemisphere. And so most of the spatial patterns that you see on this plot are very similar to what have been reported over the years by both satellite and ground-based studies. I'll note that the absolute maximum within this field of view occurs in Colombia and Venezuela, where we have over 10 flashes per kilometer squared per month. I'll also note along the west coast of South America, you'll see relative minima along the highest mountain peaks that occur in very close proximity to relative maxima in the foothills regions. And those regions are important because they often are the initiation points for thunderstorms. We have a manuscript that's nearing submission that describes this in a lot more detail, so I won't get into too much more, other than to note 2 more points. Some of the unnatural artifacts that you see here, the line artifacts and some of these other shapes, have actually been diminishing in time as the ground system is tuned. But I want to note that some of these features are unavoidable and that further analysis and fine tuning will be required to result in any further improvements. I should note also in this South America here, one important detail is if you zoom in, which you can't do right now, but on an image like this, you can actually see even the shapes of the rivers in the Amazon River Basin and the effect of the river breezes. So that's a neat climatological feature. And then the last thing I wanted to note on this slide is probably the first thing that you noticed, and it's the two fields of view that are shown for the GOES West GLM. So this is caused by non-uniformity in the GLM CCD array, coupled with the need for biannual yaw flips to help mitigate the ABI loop heat pipe issue. And so the solid line that you see for GOES West depicts the coverage during boreal summer, and the dashed line depicts the coverage during the winter. And so just wanted to note that before moving on. So then slide 3 shows two different perspectives of the same remarkable lightning flash. And I wanted to note that within this large overlap region, both the GOES West and GOES East GLM see a lot of the same flashes. And so this really helps us to better understand how the GLM is actually working to detect the lightning. On the left, you see the GOES East observations, which have been widely available since they reached provisional maturity in January of 2019. And then the GOES West reached provisional maturity in December of 2019. And so I'll play these animations again. You can see now the overview image. The structure is very similar. But as I play these back, notice as the structure unfolds, you do see slight differences between the two instruments. And what this is showing actually is for this particular flash, the GOES West saw many fewer events and groups compared to the GOES East. And this is further towards the edge of the field of view for the GOES West. And so you have bigger pixels here. And so it generally, when you have bigger pixels, it takes more optical energy to trigger the GLM. And so this has a bigger effect on the events and the groups than it does on the flash detection. As you can see now that we're back at this overview again, the structure is very similar between these two flashes, but there's about 7,000 less events for the GOES West GLM. So just to note that before moving forward. Sounds like somebody might have joined without mute on. If you could turn that on, it'd be great.
Thank you, appreciate that, everybody.
Right, moving on to slide 4 here, you can see we had some pretty remarkable animation tools already in place by the time the GOES 17 reached orbit. This storm-centered view shows the depiction on the left for the GOES West and on the right for the GOES East as these storms progress across the southeast US, the Gulf of Mexico, Florida Peninsula, and then into the Atlantic Ocean. And so again, you can see a lot of detail that the GLM is providing. It's more than just a detector, it's an imager. It sees all the pieces of the lightning. And then I'd like to note how similar the depictions were between the two. And this was using the out-of-the-box settings for the GOES 17 GLM, which has since been further tuned to improve the efficiency. So then the animation on the right, the full disk perspective, what I'm showing here is that a fairly simple combination of GLM and ABI really does a good job of showing where the energy is in the atmosphere and how it's evolving. And you'll notice as subsequent days go by, you'll see common initiation points. And this was a week ago, so it's the dry line in Texas down into Mexico. You'll see storms kind of recur there each afternoon and then progress downstream. And so these are the pieces that fit together to make the climatology image I showed you in the first place. I'll note this is the full disk for the ABI, so there's some regions around the edges of this animation that the GLM doesn't observe. And if you like those types of videos or have a picture frame, you need a digital picture frame, we have daily, weekly, monthly, seasonal, and annual versions of that. So I'll show you a link at the end to our website, and you can go look. For instance, this full disk, if you go look at one of the active hurricane weeks, it's really a neat way to look at the storms. So then moving on to slide 5, zooming into the CONUS perspective to really start to focus on the applications. The animation that I'm showing here is the GLM flash extent density combined with the ABI GeoColor product. And this is available on the NESDIS Star website, both CONUS and full disk perspectives. And so the Tower S team asked me kind of what was my call to action for this presentation today. And if there is one or two, this is the main one. We recently have been tasked with putting together a value assessment for the GLM. And this is intended to help advise decisions on future satellite architecture. And so as part of that exercise, what we've done is come up with these 10 GLM application areas. And over this summer, the application teams will be reaching out to others and compiling brief reports documenting both the economic and the societal benefits of the GLM data. And so I'd like to ask those on the call, just the whole community, if you found value in the GLM information and wish to contribute to this effort, please reach out to us, and I'll be sure to put you in touch with the proper application team lead, and we'll be sure to make sure your feedback is included in this larger effort. Before moving on, I just wanted to go over a few of these applications, kind of give you a feel for what I mean. The first one, severe local storms, that's kind of a catch-all for what we knew the GLM was going to be helpful for from the onset, and that's really in the warning operations. So forecasters using the GLM in conjunction with other data sets to get a better feel for which storms are going to become severe or tornadic. Category 2 there, application number 2, in terms of aviation hazards and airport advisories, this is another very broad category, talking both about the value to protecting life and property on the ground, and then also the obvious threat that lightning poses to aviation assets en route. And then tropical cyclone structure, rapid intensification. This is one that seems to be promising as well. Over the years, there's been a lot of research that has shown beneficial, if not kind of mixed signals about the potential to use lightning data to better understand tropical cyclone structure and its evolution. And so the team down in the National Hurricane Center has been working to incorporate the GLM into their rapid intensification index product. And so that's another really useful application. The data assimilation and model initialization kind of goes without saying. We haven't advanced that as far as we'd like, but there are studies going on showing or examining how best to use the GLM information to better initialize numerical weather models. Number 5, this is another broad category, the WSR 88D outages and limitations. By limitations, we kind of envisioned this ahead of time. We have a great 88D network, but there's gaps that doesn't see everywhere all the time, especially out west with knowledge of how the GLM observes lightning. It can be a very useful tool to help fill in the gaps. But I'm also referring to outages. And kind of ironically, I recall from my time in Tallahassee, the same storms that were producing the severe weather forecasters were warning on often would produce lightning that would take out the radar. And so in that case, when you need the data the most, you lose it. And so of course they have other assets, terminal Dopplers and neighboring radars. But if the offices know how to employ the GLM data, it really helps to avoid any kind of drop off that might be caused by losing that radar. And then I also mean the planned outages. So the ongoing pedestal replacements. It'd be good to get in touch with the forecasters ahead of time and let them know, hey, here's GLM, it can help you where you might have coverage gaps from your auxiliary radars. And then the last one that I'll highlight here, wildfire initiation. This is a really interesting application. Our science team has been doing a lot of work on it for many years, but real recently, Bisela Corporation has announced a new product that reports the continuing current in lightning flashes. And so it's the first commercial product to combine both the ground-based networks and the satellite to provide new information that isn't available with one or the other network. And so the idea here is that they will notify users of which lightning flashes produce continuing current and how long that continuing current lasts. And that's well known to be the most important lightning characteristic in determining whether lightning will start a wildfire. And so I'll be really interested to see how this product performs and then how it can roll out into the field in future years. And with that, there's the other 4 here, but I won't go into them for the sake of time. So slide 6 shows the latest and greatest from Michael Peterson, who continues to do spectacular things out at Los Alamos now. On the bottom, you can see it's a 7-day moving window. You can select the time, play, pause, speed up, or slow down the animations. On the top right, there's some really neat functionality. You can, for instance, change from 3D to 2D perspective, or you can change the background to nighttime lights of the world if you want to see things in proximity to cities. On the top left is where you select what's shown. And in this example, what you're seeing is the color of the dots corresponds to the mean flash extent, or the size of the flashes. And the height of the columns relates to the flash extent density, how frequent the lightning is occurring. And so you see in this mature MCS here, there's infrequent but very large flashes back behind it, indicated by yellows, oranges, and reds. And then along the convective line, you see smaller flashes, but occurring much more frequently. And so I don't know that it's a call for action, but one thing I do really want to highlight here is that there's a lot more information in the GLM data beyond just flash occurrence and frequency. And a lot of users are starting to recognize this additional texture and finding ways to make use of it. And so I encourage you as a user to look at some of the derived products and think of how you might combine that and work it into your application. So then I'd be remiss if I didn't show GLM gridded products as available in AWIPS. This flash extent density shown on the left here has been available to forecasters for 2 years now. The warmer colors indicate more frequent lightning or more intense storms. And I'll note the close co-location between the most intense storms indicated by GLM and the severe thunderstorm and tornado warning polygons indicated by the yellow and red. And so that's, now you look at the right panel, it's the average flash area. And again, you can see the large flashes back behind it indicated by purple, and you'll see them out in the anvil as well. And I want to note here that this average flash area is going to be replaced this summer with the minimum flash area. And this was determined at the hazardous weather test bed and other test facilities to be better able to show the features that we think forecasters will find most useful. And really this is within lines of storms or individual storms, stronger updrafts tend to result in more frequent but smaller flashes. And in some cases, you can actually see the constricting of the updraft evidenced by even smaller flashes. And so this is an example of how we're trying to work this additional texture into the forecast operations. And then there's some RGBs that folks are starting to work on too. And then slide 8 here shows some more experimental work that we were able to do over the past winter. We started with the premise that it would be advantageous to define storm features using only the GLM observations, or at least the boundaries of storm features. The images on this slide show results using the HDB scan algorithm. On the bottom left, what you see is the GLM groups that are shaded by a cluster probability. That's the likelihood that that group is included in a specific storm feature. And then I simply drew convex hulls around each of the storm features, or all the groups in a storm feature, at 2-minute intervals. And then on the right here, what I've shown is just an accumulation of those polygons, changing the color every hour so that you can see them a little easier. What you end up with is a really cool kaleidoscope effect at the end. But what I wanted to show, even though you do get some wonkiness and the polygons jump around more than you would like, the computational efficiency, I can throw tens or hundreds of thousands of groups at this algorithm and get clusters results within seconds. And so it's very, very encouraging as a potential tool to be added to the GLM architecture down the road. And then in the top right panel, what you see is this is actually an HTML page that's created in Python using the Plotly toolkit. And what it's showing is a full day's worth of storm features. Each dot corresponds to a 2-minute storm feature. The size of the dots indicate the number of flashes within the storm, and then the color indicates the time of day. And so this is a really neat thing. Again, since it's HTML, I can update this in real time. And when you go to the page, you can hover over the dots to get additional drop-down information to query the storms. And so I wanted to make sure it's very experimental still, but I wanted to show you that we are considering these types of things. And then I'd like to conclude with the 2 GLM links. The top one there, this is the GLM imagery page. It provides a lot of the same imagery that I showed you today can be found on this enthusiast tab. You can see daily flashes, the most extreme flashes that Michael Peterson's algorithms catch. You can see daily videos of those, and again, the long-term summaries that I explained earlier. The Forecasters tab has a little bit of training and a couple of other examples within the AWIPS software. Real-time links to 3 different real-time sources of GLM data. And then the DIY tab, we're still working, but there is some information there to help you know where to find the GLM data and how to begin to work with it. And then the last point, I wanted to note that the COD meteorology page now offers GLM flash extent density as an overlay. And so those that use the site are probably familiar with how to find it, but if not, you go to the product overlays, goes derived, and then the flash extent densities down here. And they also show the L2 flash points, which is helpful to look at. And so with that, I'd like to thank everybody for their attention, and I think we got plenty of time for questions.
Yes, Scott, thank you very much. That was a great presentation. So at this time, we will open it up to questions. And again, with the size of the audience here, we do encourage you to please ask your question in the chat room. If you'd like to ask a question verbally, just mention that and we can unmute you. But we'll open up to questions here. So does anyone have any questions for Scott?
Scott, thanks. Jordan here. A lot of our field staff during severe weather situations are concerned with many different storms, have limited real estate on their screens. What is one field that you can recommend, or one procedure that you can recommend to incorporate GLM into a warning type process?
Yeah, I mean, we've seen the one, that's a tough one to answer. We've seen a lot of examples of it being incorporated as multi-panel. So for instance, Jason Jordan out in Lubbock has shown us a couple of examples of how he'll look at the data kind of on its own. But in terms of incorporating with the existing data, if you're working with just satellite, a simple combination with IR is nice. And one thing that I don't know if folks have explored too broadly is to fool around with the color scale a little bit. If you're trying to just combine it with visible or IR, you can just use kind of an 8-bit radar color scale for the flash extent density. And it almost looks like radar, especially if you're zoomed out to a regional view. And so I recommend you just if you have time, not an active shift, and try to fool around with those color tables a little bit. Recommend that. So I don't know if I
Yeah, thank you, and thanks again for your presentation. Other questions, particularly from NWS staff out there today? Maybe, Scott, if you could just remind us of your call to action, your calls to action.
Yeah, thanks. I thought that was a good, Joe sent that in an email a day or two ago. But yeah, really this value assessment. We've worked so hard to just get products in the right format and into the office that we haven't had as much time to really gather the feedback that we'd like to. And so if you have found value in the GLM and you haven't found a venue to share that with us, please just reach out directly. And we'll put you in touch with the right people to share that feedback. We definitely want to make sure that we get feedback from as broad of a segment of the user community as we can. And so that's one thing I want to stress. And then the other, I don't know if it's a call to action, but to look for the additional information in the GLM beyond just lightning occurrence and frequency. Look at some of these other higher order levels of information and think how they might be incorporated into your workflow.
Okay, maybe just as we wrap up, again, we'll just leave it open for any questions here. Scott, anything that has surprised you about the GLM?
Yeah, I guess lots of things. Other than just the capability, the fact that we didn't know before we launched it what it would do, and seeing it in action has been remarkable. But the thing that has surprised me most has been the complexity. Not just the complexity of understanding how the instrument works, but the whole chain from the data coming off the satellite to getting to forecasters' fingertips has just been, I knew it was going to be a challenge, but just the layers of complexity has been very surprising. But we've managed to persevere and think we're in a pretty good spot.
Perfect. Last call for any questions out there. Okay, well, a crowd that was listening today, 80 people, that is fantastic. I hope everybody in the audience is staying well in these continued challenging times. I hope everybody's planning on joining us next week. Thanks, Scott. We have somebody have a question.
Yeah, Jordan, there's a question in the chat from Chris White.
Okay. One more question here. Any research going on with TOE values and potential operational applications?
Yes, that's a good question. So the three experimental products that we started with that we were really focusing on were the flash extent density, the average flash area, and the total optical energy. And I have had and probably still to some extent have high hopes for the total optical energy, but it's the one that's most sensitive to the satellite observations themselves. And so we've seen enough instances where the signals we expect to see aren't really evident within the total optical energy product that we've kind of paused a little bit in terms of recommending that as a standalone product. The optical energy has great value beyond that, and so we continue to see how to work it in. But in terms of its own visualization and AWIPs, it's still available, but we're shying away from recommending it right now. So I guess stay tuned.
Okay.
So thanks again, Jordan, for the opportunity here today.
Yeah, no problem. Thank you, Scott. And thanks, Brian, for calling my attention to that question there in the chat. I'm sure if anybody else has a question, you can get in touch with Scott and he'd be happy to interface with you. Feel free also to reach out to our Tower S team if you're interested in training or getting this data in AWIPS or how to access it. I hope you're planning on joining us next week, Thursday, June 11th. We have a forecaster from WFO Amarillo, Caitlin Rutt, and she's going to be talking to us about how satellite products assisted with some severe weather operations on May 7th in the Southeast Texas Panhandle. And with that, I hope everybody has a good weekend whenever that comes for you. Take care. Please reach out to us. Thanks, Scott. Thanks, everybody, and stay well.